into a poster because we like making images. So we hoped that having those around would help people. And these are for the most basic of imaging modalities and the most common: wide field confocal and spinning disk confocal. We also included example checklists where we could say, for your average wide field imaging experiment, what do we recommend you have and what do you really need to, right? So we included those components and an example text of what that would look like, because everybody said there's no way I can include that in my methods. It will be 8 pages long, and it's not. Right, you really can write it and have it be a paragraph and include all the relevant information, but many people grew up in a Mad Lib style writing for papers, and we wanted to include that for them. But people were like, the checklists are still too long, this is too hard, I'm not going to use it. So we made MicCheck, and this was really led by Rebecca and Paula, and it is a Shiny app. So this case was presented with that paper where you have examples of metadata, the user answers quick questions and makes their own custom checklist. So they're asked, what kind of image modality are you using? Multiphoton, confocal. If you were acquiring this, hopefully it would be very easy for you to do. Did you use time lapse or any other multiple dimensions, multiple colors? As you answer yes or no, the checklist on the right adapts. So things that you don't need aren't on there, right? And then you can look at examples as well by toggling them on and off, and you can print that so that then you have something that you can take for your particular experiment, because everybody's experiment is incredibly unique and they want their own one. So that was great. We hoped that any scientist using a microscope would use this for planning their experiments. I've found it really helps students because as they make this and they think about what they're going to do for their experiment, they immediately have to start thinking about the compromises. Do I really need every color, every position, and every time point in every data set? Or could I break it down into more bite-sized places? And that for writing grants, and papers, they'll feel more robust, that they really hit the reproducibility issues. We also hope core facilities can use it, because it's hard for me to respond to an email of, can you help me with my methods in a robust, timely way that's accurate and timely and reproducible. And then for editors or reviewers who have never touched a microscope, how would you know what you should be asking, right? And this way you can be like, well, they did multiple colors and they didn't report on what filters they used. That's an easy question to throw in and make you look like more of an expert in the field, right? You don't need to say that it was wrong, but just ask that they report it. And speaking of core facilities, since that was our group, we decided to make MicCheck V2. So many users don't know the name and model number of their microscope. They know that it was called Artemis or Zeus, and really cute names that other core facilities have named their microscopes. I use boring names because they'd already taken Harry Potter, but still working on it. I think we're going to go with Pokemon. But then it will load everything in. They don't need to know which 10x objective it was, because I knew that, right? They just need to tell me, I use the 10x on Zeus. And all of that will be immediately filled into their checklist without me having to copy paste things from the website. Okay, so this allows you to store metadata and do it just using an Excel spreadsheet, right? So I change the 10x, I can make a different version and easily change that. That's within most core facility directors types of data generation, right? And we can have custom examples. So I do a demo, I can have that appear, and I don't need to store that information in my brain or in another way. So these are all on GitHub. We're still working on it, but during this time, again, funding has changed. So it is kind of waiting for somebody to take it up. It is currently at its best use case of being out there and capable of anybody with a bit more interest to pick up and run with as you would like. And then, of course, the last step is writing, right? So how do you get from there to this paragraph? I tried making Mad Libs on a Google form. I don't suggest that. You can, it gets really weird. And of course, during this time, large language models and computers came out, right? So couldn't a computer do this better? We took a first step, and so don't make fun of us, be very kind, at what we called methods J2. And that was because Mark Sanders' group had done methods J1, where in Fiji or image J, you open an image and it will report out the methods from the stored metadata, right? That was okay. But we wanted version 2. We wanted to be able to ask a few questions to validate the metadata, or even to import data from a core facility to make it better. And that's what methods J2 was. And so in this case, you open an image in Fiji or image J, it'll ask you, it'll say, I think you used this objective. Is that true? And then from the objective name in the metadata, it will fill in the core facility provided text that is actually human readable. Right. And so we have those translations going, and then it spits out eventually a block of text with a lot of disclaimers to read and to try to make sure actually makes sentence information. So that was our implementation of what could be an automated text generation from the metadata. But of course, this is a growing field, and we now have technology that could do that to a much greater extent, but we don't currently have the project bandwidth to push it to that next level, but we think it could be a very amenable next step for people. So other working groups are working on this. I promised other open source groups. So besides the OME, there is what is called QUARUP-LIMI, Quality Assessment and Reproducibility for Instruments and Images in Light Microscopy, and they have maybe 18 working groups now, something quite high. They have people like NIST on it doing NISO image calibration, details, and things on like, how do you know if a camera is good, right? Or an objective, what does flat field mean? Those are other working groups. The one that I was working on was how do you publish or analyze data and make it more interpretable to others. And those are led by these current group heads, pulling across the entire globe, people who are working and interested in this. And they have put out more publications on any of these standards, right? So for this, they have another one, another checklist, I know, but this has now been validated across multiple global communities and includes image analysis. And that includes things like if you are going to make a workflow, what is recommended, all settings, but what is ideal to document it with a screen recording, right? Or a tutorial, things that people who were coding before knew, but most of my researchers had no idea. Making example data sets. So this is now accessible for the researcher who's starting a project to figure out how they might make custom code or workflows and interact, and when they get stuck, who they need to talk to enable that step to be more at a higher level. Okay, so those now all exist. They made another poster, right? So there are more posters that people can put up that are now just with presentation of the data and how to do colorblind friendly. We're getting to more than 20 different signals. How can you present that? What are some of the best practices? Things like that. Okay, so the last thing I wanted to do before we open up to more discussion was just to emphasize that all of this really relied on having interactions between core facilities. So that's one of the things I'm so excited about here at UNC is that we have the RDMC, which is officially a core facility, right? A node to bring together expertise and specialized techniques and provide them to the community. And what I would encourage is that if you have reached a stumbling block or you have reached implementation with a single user group, to engage your core facilities because they are speaking your same language. They both want to educate, they want to automate, and they want to make tools easier for everyone. And they often have those connections to whichever use case you are looking for, whether it be highly advanced or the average, quote unquote, robust one that we can grab for you. So thank you all, and just very interested in what you all of the ideas that you might have.
Thank you so much, Michelle. This is incredibly interesting, and I actually see some messages during this from maybe from some people in the room.
we're different, right?
So I guess we can open up to questions. Y'all have online people
Oh.
with questions yet? No, okay.
So it's like
I can, first slide. Okay, thank you. So Mike, first of all, thank you for a starting talk. I'm Roberto from the Research Center in British Germany. And just recently, I've talked to people that are not doing microscopy imaging, but they're using TEM, so electronics microscopy, you know. And what they told me is that they are looking into creating digital twins of their electron microscopes, so microscopes, something like because they have that problem of they have like groups of stuff where they need to focus the beam and like easily go to like 10 to 20 things that need to adjust just to turn out at the same error and things like that. So is this something that you're also looking into within the like light microscopy world, or is this too far away?
Yes, so we have several, I guess we would almost call them simulated microscopes. And those have been very powerful for teaching people digital pathology, and how the optics defines the image and enables them then to become early entry analysts, right? Without access to the hardware right there. So that's where the imaging use case has been, is if they can understand how the image is formed using a kind of simulated image or microscope, then they can analyze them in a better way, right? And so that has been used more for education and then for trying to link tools. So what I would say is the proprietary software companies are investing a lot on being able to overlay multimodal data, because they are trying to get people to buy their suite of instruments, and then say, I acquired this same sample on this, and this. I want to look at them all at once. And it seems like it should be easy, but has been incredibly difficult because they almost all have some warping, rotation, scaling issues. But in the researcher's mind, stick a few fiducials on there and it should be super easy, right? So there is some element of work towards that I'm seeing people do as well. That is kind of coming out from the super resolution field as they're doing early EM to light microscopy and MRI to light microscopy kind of validation.
thank you for the presentation. And is this just light microscopy or any other electron, whatever other particle microscope to be used? Is there any difference between the type of a particle to do?
So officially for Omero, right, it can load all types of data, right? So it has MRI, our UNC one has some MRI data on it. It has some EM. If you are doing volume EM, you get to the large data cases that are more like the light sheets, where you have very high resolution data sets, right? Like they can be petabytes of data, but very similar. And what is being used by the volume EM community is often similar to based on an Omero-based database. And I think that's SSDB has a bit more of those, but we have also included videos. So in the clinical side, often digitizing videos of clinical appointments, or on the preclinical side, mouse movement has not been saved in much of an interpretable way. So we can add in those video files to Omero, so you have a file with that mouse's behavior and then anatomy and downstream sequencing or things like that if you wanted. So you can layer different types of data. It can visualize blot images, things like that as well.
So, and is there any it's about metadata field, so it might be confidential or HIPAA related, so you have to mask or you can handle under certain condition. How do you deal with such issues?
So that would probably be our last bullet on our current implementation wish list, right? We don't currently have any clinical data on the UNC Omero server. It must be preclinical or de-identified or by the time it reaches Omero. We are talking about making a clinical data Omero, and what I would say is NYU has made one, and multiple others, and they actually find that it's easier because you have going in a project scope that we don't have on the preclinical side. You know how many samples you will have, you know what resolution they will be, and you can map them to a pre-made spreadsheet. Whereas with our preclinical researchers, they have no idea. They don't even know what microscope they're going to use yet. So it only grows, whereas the other one is more contained. But there are Omero instances that are clinical data.
Okay, another question from the audience.
Perhaps wondering how this works, all these microscopes, you get 10 images, is the metadata that we want to actually put in the paper embedded in each one of the images, or could you have, could talk to the manufacturers and have them agree on a standard where there's a file inside that could be put into Omero Dataverse? It just seems like that's the time to capture that information.
Agreed. And so that's what Omero had been fighting for years. I'd say one company currently allows for a direct save to OME-TIFF. The problem is that original OME-TIFF data file format did not have space for the hardware commands that are needed to reuse settings. So they need to, Josh Moore was talking something about file format models that I didn't understand, but the new vision is to create one that is capable of it. This is the minimum required and everything else can be optional, but still maintain that data metadata saved. That would be the ideal. The problem is the proprietary ones, just like all of us, have been built off of things that started 40 years ago. And so if they were to switch now to one that built this, they would lose capability in the short term, and the market incentives just don't help for that. So what we are working on is external tools like Fiji or others that can automatically do a file converter, essentially, to make, and then maybe you could select, I want this to be cloud-based, which will be huge because my users get curious and they go click, and then all of a sudden they're like, why is this huge? Because it's pyramidal and it's saved in all the different ones, and wasn't meant to small computer. Or I want this to be for visualization and it'll downsize and just take a few of the layers or something like that. But we don't quite have that tool yet. There are goals to put in grants if they keep funding infrastructure, or the other idea that we saw with IDR is that governments invested and said that it was worth it for them to become hubs of data development like that. But yeah, I agree, that would be the ideal. I would even like a little the little paperclip to be bouncing, right? So that like as they're acquiring, they're like, just a reminder, right? Like you have a lot of saturated pixels, right? That I'm not going to stop you from acquiring it, but if you need to know why that could be an issue, this will take you to a resource that tells you potential strategies and troubleshooting. So I think we're getting there, but we're not quite there yet. Yeah.
So I have another question. Omero seems to me like something that you're using to manage like the hot data, something that comes fresh after Microsoft, and you're analyzing it, you're sharing it like with your co-peers, stuff like that. And what you describe is like that when people use this image data to like create illustrations and the papers and stuff like that. What I've missed from your talk was like, is there a link to like what most of the people in this group are doing like the long-term archiving or these repositories like Dataverse that are others as well, of course. Like, what's your take on what's like the perspective of the community on like moving like beyond Numero and maybe even keeping that metadata around and shifting all of this like along with the data itself into something like a publication repository and getting the UI of this stuff and linking again to this data publication from the tech publication.
So what I would love, and what we've kind of talked about for years, right, is this idea where we could have something at UNC where you tag a file that this is now going to be a paper for submission. It creates some sort of public-facing, non-tracking, view-only version that reviewers or editors could go in and look at the full data set if they wanted, with relevant metadata attached. And then we would have a "it was published" button that would move it. It would store it in some way, and ideally create Omero as a tool that could be launched, right? So in that case, we're not using it to actively manipulate the data. It's really just visualization and sharing. And it would say you find it through Dataverse. It has this DOI, and attached with it on the right will be a human readable description of what this file is, named 2088, whatever, right? And so that somebody won't click on all of them, right? But you could, because it would just launch a temporary instance of Omero that wouldn't save anything, right? But would allow you to visualize it, to change contrast so that human eyes could see it, and see, is this something I want? And if so, then I would request it. And if so, then there could be more validation on that. So it is officially publicly viewable, but we don't need to store the high resolution set for anybody to click on and then start downloading immediately. And ideally, in my mind, there would be the option like, are you going to be reading this on a cloud or on a local computer? Because there are different versions we could provide for you depending on that. So yeah, I think that would be my dream, is to open it like a tool that is then very robust, would adapt as the user base changes. So then all of a sudden it's not Omero and it's something else. And that's fine, right? And we move to that, which is possibly built on an entirely different backbone, and enable people for things that are more video or something like that to view it in that format that's best for them.
Yeah, we're looking toward basically this community, Omero previewer is what we're looking for. There's a lot of issues with that, with all the massive things, but also infrastructure that John is working to build that moves data around, and maybe doesn't move it but tags it. So you don't have the huge images, you don't really move them, you tag them, and then using a tool like RSpace to publish those links back in Dataverse without moving the data either. RSpace will know where the data are. They're tagged, they're now archivable, no one can touch them, they won't get manipulated anymore. And then when Dataverse gets it, it just opens this Omero previewer. Now, we're still not there yet, and honestly, we started back thinking about these types of things back in the brainy era at Odom. It just takes a long time. This is a really tough nut to crack, but we've got some great folks on it now. I think it's going to be cracked this year. I think next year at this time we'll have an answer. Do you have any more questions?
Yeah. So this is kind of a UNS. This is very UNC relevant thing. I wonder, it's when a researcher requests imaging, what kind of request submission system do we have? So kind of wall-to-wall online system, or are you using a special phone call, or putting the data in spreadsheet and or sometimes paper, and then just send the image to researcher? Is there any complete wall-to-wall online system request right now?
That's a great question. So I would say NYU does what we would call fee for service imaging, where a researcher consults with them, provides them a sample, their staff do the imaging, and they provide the images to the researcher, right? We don't, right? So they have a slight pipeline for what that is, and they helped present that at the OME meeting. We train individuals to use the microscopes, and then they are the ones bringing in whatever samples they choose to bring in. They can collect for 10 minutes or 10 hours over years or one visit. And then they are supposed to take the data off of our acquisition computers by the time they leave. It's not exactly true for some of the bigger data sets, but that's in theory is that we don't store any of their data. So they have to have a short-term image transfer. It's typically at UNC done by servers. Internal department servers is the fastest way to change data. But then we encourage them also to do Omero. So Omero is on the acquisition computer. It has its own uploader, which is very clunky. That they are working on updating that works, right? But is based on open source software from the 2000s, right? And so then they do with it a million things. They may download it onto their computer, convert it into another format, open it in a proprietary or an open source software. We can save things like cell profiler, recipes on there and link it so that the output you can see on your image, how many cells there were in this image, how bright they were, but that kind of has to be run and that had to be linked. We have a few pipelines of common ones that require or we suggest conversion for, but we don't currently require anybody or have policy on what data they can upload and what they can't, and what alterations they could have made to the data or not, and what they can't. And so we've been under talks a lot because we theoretically don't own it. And so how can we make that policy robust and still worth it to the users to use?
So, is it too much to fill a data before the request? Is it too much for researcher to fill out the metadata before requesting an imaging?
I wish I could say no to that question. Unfortunately, all pilot tests have been that it is too tough. We have tried coming up with a little GUI that says, what are you imaging today? Right? Can you link it to a digital notebook? Is it a mouse or a tardigrade or a human finger? Like, I don't know, right? Can you tell us what that is? And we found that the first time somebody developed it, they were really good about it. And then the next time they just go enter, 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 right? And it's just not correct anymore. It's just a step that is skipped and very difficult to validate without the original researcher. So one option was having at least some policy where we need something to be linked to it. And that is what is required to get out of temp space into actual storage. Because if not, it's just really not going to be usable by the researcher or anyone else. But determining what that is probably still going to be too little to actually reuse is my gut, but at least it will be a start, something to begin with.
Wanted to pass along compliments from the online audience for the presentation. Very inspiring, easy to follow. But I do have a question. So something you talked about yesterday in the session about trust was our relationship to our end users, to the scientific communities that we serve. And one thing I think that's important for us is to engage and not be speaking to ourselves in this echo chamber. We look at your policies, we look at your equipment, your technology, but I'm wondering what else should we try to learn about the communities we serve? So whether it's specifically, it could be their culture, their habits, I'm not sure. What should we get to know about our users?
I think you would be surprised by how many steps are in the data analysis. pipeline. So if you follow, and like they're in physically different locations. So I know that we've had some of our proprietary software engineers who often are local in Chapel Hill, which is awesome. And they will come and they will just sit in the core for a day and by our workstations, and some do it virtually, but some just come in and it's just like, what are you working on? Right. And they're like, I'm doing this and I'm converting this one on my laptop and I'm doing this on this other workstation. And you're like, why? Right. And they'll be like, because I tried that other way and it took too long or whatever. And then you're like, well, maybe it's because you were using a USB 2, right? Or whatever that was, but they don't have that language yet. And so I think that those actual like walkthroughs of seeing their steps have been incredibly powerful. And them understanding that you all are a core, right? Like you are, I think often the kind of IT system is towards efficiency and tickets, and like you don't get the same name. Sometimes their name doesn't even show up when you're online chatting. And UNC at least is a lot about relationships. And I think being like, oh, this person knows that I'm interested in this random brain cell type that like maybe you're not interested in, but you can be like, I know you do that weird thing with lipids, or I don't know. And that makes them feel more, I think, partnered, right? And so I think there is an element of that, which sometimes interacting with the PIs or the deans won't get to, but the students actually touching the data will do, because I think a lot of times the PIs don't even see the steps, right? They see the outcome and they're assuming that it was similar to when they were acquiring the data, and it's just evolved so much beyond that. And I think also starting early, right? So I wish, and one of the things we might do with our incoming graduate students is talk about how do you, like, beyond rigor in general, just what computing do you need to succeed in graduate school here at the university? Because the number who are fourth years and they're like, I have a data drive. And I'm like, great. And they pull out a thumb drive that's like 2 gigs, right? And I'm like, that's not gonna cut it, right? Like that's not, and just telling them like what the difference is between types of storage, I think will be new, and that will feed up. Then they start doing, the labs that we saw do that started doing a state of the data annual address in their lab meetings, right? So we're seeing new PIs start to do that. And I think just knowing that that is a thing that other PIs will be interested to replicate. They're like, what do you mean? You have a standard file naming convention, right? Like how? And then I think seeing the public present things like that, it's just like you see the light bulb go off. But I do think starting with the students or the technicians could be a good way to build it, because they're the ones training the next ones. And then they're like, this is how you do it, right? And then we see it take off much more.
I think our time is about up, and you're probably ready to get off that stage. So if actually time in the next. Just a couple of announcements, I think, and we've got a few minutes before that says that we'll transition to it.
I know, I got it. We have, these are the 2 links, right?
Oh, so you got the 2 videos?
Yes.
All right.
Which ones are, I just got.
They
your email
haven't,
here.
oh,
Sorry,
No. All good.
I was not checking my email, I was watching the presentation.
everybody has your videos, right?
Hmm?
Everybody has your videos for me, right, to do a video presentation
That's what I'm.
right now.
Yeah.
What would be the easy?
And now you're ready to go, and then no one can see you here. And online, see?
Yes. All right, folks, you see it. So the 2026 12th Annual Dataverse Community Meeting will be held at the Barcelona Supercomputing Center in Barcelona, Spain. So get ready. Start planning ahead of time. Now, we have, let me make sure we have make sure this is sharing. Yep, it is. And I'm trying to.
Welcome to the BSC Dataverse, an idea made possible thanks to all your insights during the Mexico Community Meeting.
Desde Barcelona les damos la bienvenida con los brazos abiertos.
Hi, Dataverse community! We can't wait to have you here in Barcelona. Benvinguts!
Okay. And is it just Philippe Conzet?
That's right.
All right, we have some announcements.
Yeah, so on behalf of the Global Dataverse Community Consortium, GDCC, I just want to thank the local organizers, John and his team. We've seen all of them putting a lot of effort and hard work, commitment into planning and organizing this so smoothly and making it a rememberable event for us. I got a long list of all the people contributing to make this happen, and I'm sure there's still more of it. So it's the whole the RDMC team with John, two Johns, and we have Heath, Blair, Thumai, Rachel, Mandy, Luna, and Don, and I think there are others also making all the technical stuff smooth and pleasant. And I also would like to thank all the presenters for all the interesting presentations and the roundtables, the keynotes, and also all the attendees, of course, both here in person and online. For many reasons, we were kind of smaller bunch than last year and the year before. So, but I think it was a very good event. A lot of interesting discussions. Yeah, and I'm looking forward to next year's event in Barcelona. And Stefan also would like to say some words.
Yes, I want to share the same gratitude to John and his team for making this happen, but also all of you for attending in person and remotely. Lots of discussion. This year I was able to bring all my team here. And so also on behalf of my team, I have to thank all of you. I think it has been another incredible year. It's just the beginning for the next year. So we will see what we will get to the next community meet. But the reason also I'm here is because there is an announcement I want to make. Can we have the guy on the screen? Or I don't see.
Oh,
Can you help me?
okay. Stop.
Maybe. There's a guy in the community who makes a lot of noise. So I want to officially make a statement about him. Can we see the, not me, not the old guy? Bit of suspense. Okay, should I?
He's online, they can't find his picture though.
No, I want to see his face. I want everyone to know. Pin. Slava, show your face. So on behalf of the Dataverse core team, which includes also Don, Jim, which is giving a seminar on my behalf now, and Eric. So we would like to announce actually, that we have named this guy, which is Slava Tikhonov, the first official ambassador of the Dataverse project. This is an official, charge for you. So now be careful what you say on behalf of the project. Arrow will chase you. But anyway, let me give you the motivation. So Slava has been an extraordinary community member, tirelessly sharing his expertise with this team and the community and everyone he meets, presenting data at conferences across the globe, maintaining multiple installations, always committed to advances open data infrastructure and supporting fellow adopters, make him a natural choice for this new role that we created just for him. And maybe new ambassador will come, so please do the same as Java is doing. So please join me or us, the core team, in congratulating Slava and thanking him for his continued leadership and enthusiasm for the Dataverse community. Thank you, Slava.
Thank you, guys. I don't know if you can actually hear me.
Yeah, please say something. And now, because of, you're an ambassador. Diplomatic now.
Thanks. Thank you very much. It's a huge honor for me. And I joined Dataverse community. Actually, I tried Dataverse in 2011. It's already 14 years ago. Honestly, I didn't like in that time. I thought, well, it's a bit complicated. So we started to build our own system. So it came back to me in 2015 when we started to implement data repository, and International Institute of Social History in Amsterdam decided basically to use Dataverse. And I was assigned to this project to build something interesting. So I started from historical maps. And apparently, after building this exciting stuff, I discovered that Dataverse is not bad, and I saw some ways to improve it. And yeah, it's already 10 years. I still like it, and I have a lot of ideas, a lot of plans. Sometimes my ideas really scaring my colleagues, honestly, but it's normal. I can also share that I've got also invited by Neo4j, which is one of leading graph technologies company, to join committee on MCP, on the Model Context Protocol, with Anthropic, Google, and other founders. So Microsoft and GitHub also will be joining. So it's also second nomination in 1 week. So I don't know what I will do with it. I need to think about because I have to travel to US, it seems, still, somehow. But
you cannot refuse this nomination. So you can reject.
No, thank you very much for your support and your belief. Well, I really will do, I will try to do my best for Dataverse, and I really believe that with Dataverse, we can solve a lot of problems also, world problems. So thank you again. Thank you very much.
Thank you, Slava. I think now it's Sonia again. It's you again. I know, John. Sorry.
Yeah, let's do videos.
This video?
Yeah.
Okay.
Hello all at the Dataverse community meeting. My name is Janet McDougall, Archive Manager, and I'm introducing the Australian Data Archive on behalf of the ADA team. ADA was established in 1981 with focus on the provision of highly curated, mainly quantitative data in the social sciences. In 2017, we migrated from the Nestar to the Dataverse platform, so we have been part of this great community for a while now and wish we could be here in person. We're based within POLIS, the Centre for Social Research and Methods at the Australian National University in Canberra, Australia's capital territory. See the blue star. Mate Mitrev, developer, will showcase 2 applications we've developed to integrate with the Dataverse platform.
At the Australian Data Archive, we have 2 applications which we have developed in-house, Cadre and Adapt. Cadre, Coordinated Access to Data, Research and Environments, is a decision-making framework implemented as a web application that operationalizes the 5 safes. While the majority of ADA's datasets are accessible via download through its Dataverse instance, ADA is replacing the Dataverse guestbook functionality with Cadre to provide a robust set of decision-making processes and tracking for data requests and approval or rejection. When a set of users are approved for access in Cadre, a Dataverse provisioner component adds the set of users to a pre-existing group in Dataverse that has been configured to provide file download permissions to the requested files. A flow-through from Cadre approval to Dataverse access is automated. For a more complete explanation of Cadre and how ADA has integrated it with Dataverse, those interested can view informational videos on our YouTube channel. The ADA archival processing tool, Adapt, was developed to ensure ADA's archival flows follow formal processes based on the Open Archival Information System, or OAIS reference model. Adapt integrates the OAIS with Dataverse infrastructure via API calls to support the flow of dataset deposits, archivists processing and curation, and data dissemination for secondary use. Adapt implements Prov-O logs to ensure provenance is captured for all Adapt functions. Adapt also provides the capacity for reporting, internal notes, and user management, providing a complete web application experience.
The Harvard Dataverse repository introduced its paid large data services last in 2024. Our large data services are provided by a team of people at IQSS. The service is supported by members from our data curation, finance, software development, and technical support departments. As you are all aware, the last decade has seen increased demand for large data support. Research has become more data and compute intensive. At Harvard Dataverse Repository, we have seen an increased number of requests for these services, including a demand for large data storage, stewardship, and computing. In fact, over the past 5 years, we have received over 120 tickets about large data support. From hospitals, Harvard and non-Harvard researchers, groups, and US government departments, ranging from 1 terabyte to 950 terabytes of storage. Requirements include immediate and individual file access, support for millions of files, collection growth, versioning, restricted content, indefinite retention, and budget-friendly options. When developing sustainable large data services, we identified 3 key challenges and considerations: technical, curatorial, and administrative. Technical limitations on large data storage infrastructures strongly influence how we curate the data itself, particularly how we arrange it and the number of files allowed. Here, we summarize some of the key challenges and considerations. Key issues are sustainability, data storage, access, and file arrangement, speed and type of user interactivity via UI or API, and the cost of storage and upload/downloads. We are fortunate to have access to large data storage options through Harvard's relationship with the Northeast Storage Exchange, NESI. NESI provides low-cost tape and disk access to Northeastern academic institutions with no upload or download charges. We utilize the Dataverse integration with Globus for this support. Although Harvard Dataverse is a self-service repository enabling users to create an account, then deposit and publish their data, our large data service offerings are high touch and require a consultation and payment upfront for storage. We offer services across 3 categories: pre-service support, including consultations, letters of support, and quotes; large data curation services, including free and paid options; and large data storage and access services for AWS S3, NESI Tape, and NESI Disk. To make these services sustainable, we require a 6-year commitment paid upfront. This enables us to defray the cost of future collections maintenance while anticipating some reductions in storage costs over time. Next, we will discuss these services and specific use cases in greater detail. All of our documentation, instructions, and intake form are available on our website, support.dataverse.harvard.edu. Hard requirements on data packaging are included in the documentation and in the intake form to ensure the project can be repackaged for the support selected. README documentation is available for both upload and download of data via Globus to the storage infrastructure. We developed our large data use case in collaboration with the Gray Co-Petition utilizing a 12 terabyte project from the Decode Lab at MIT. This document is available in Zenodo. Thank you.
Here are 2 more types of changes that we hope will make data more findable. The first is a change to the Dataverse account page, which lets users add an ORCID to their account. After logging into my Harvard Dataverse account, I can go to my account information page, click Add Authenticated ORCID, log into my ORCID account, and confirm that I want to add my ORCID to my repository account. Then when I create datasets, my name and ORCID are added to the author metadata fields in case I need to include myself as an author. To add an author that's a person, I can search for and select a name from the ORCID API, and Harvard Dataverse includes that person's ORCID in the metadata. To add that person's affiliation, I can search for and select a name from the ROR API, and Harvard Dataverse includes that organization's ROR ID in the metadata. Similarly, to add information about who funded the research that produced this data, I can search for and select a name from ROR. We also changed how this information is displayed on the page to indicate that the information the depositor added about authors and funders includes orchids and roars. To help us validate our understanding of user needs and behaviors, promote its successes, continue improving the design, and improving other parts of the deposit experience, we're conducting different types of UX research that builds on the work of the UX working group, including usability testing and benchmarking.
Hi, I'm Philip Durbin, a developer for Dataverse, and I'd like to tell you about a new feature called Croissant, a metadata vocabulary for machine learning datasets. Here we see a dataset on our demo site. Croissant appears in two places. If I click on metadata and then export metadata, I can see Croissant as one of the options. Croissant is JSON LD based on schema.org. One thing to note is that for files that have been successfully ingested, you can see information about the columns or variables such as description or data type. The second place Croissant appears is in the head of the HTML document. This is for tools like Google Dataset Search to be able to show the world that your dataset supports this new standard. Here we see a link to mlcommons.org where you can learn more about Croissant. The Dataverse community is actively participating in the Croissant working group, and everyone is welcome to join. You're welcome to play around with Croissant on Harvard Dataverse or on our website at demo.dataverse.org.
Thank you for joining us for the Texas Data Repository's annual activity report for the Dataverse Community Meeting 2025. The accomplishments highlighted today are the result of incredible work by the TDR Steering Committee members. The Texas Data Repository is a collaborative effort currently supported by 12 member institutions across the state. Our community continues to grow, strengthening shared infrastructure and practices.
This year, the TDR has seen a number of important developments. First, the Dataverse software was successfully updated to version 6.6, ensuring continued improvements in performance and functionality. We're also engaged in the core Notify project, which is working to connect data in the TDR with publications in DSpace institutional repositories, strengthening the link between datasets and scholarly communication. A best file formats guide was created and uploaded to our shared wiki in February 2025 to help users better understand how to preserve their research data. We've also produced several instructional videos focused on using the TDR and on research data management best practices. Two completed videos cover README files and tips for searching the TDR. These are available through our user guide and YouTube playlist. In addition, we develop larger data requirements to support researcher needs. And lastly, the Dataset Retention Group has recommended how to align TDR practices with state and funder expectations for data retention.
Over the past 8 years, the TDR's user base has steadily increased, and we now have over 2,000 registered users. We currently manage more than 3,000 datasets. The majority of these are openly accessible online, supporting transparency and open research. As of March 2025, there are 219 active API tokens in use, supporting integration and automation for about 2,000 users across the platform. Thank you for watching. We are proud of the work being done in the Texas Data Repository and the Dataverse community, and look forward to what's ahead.
So I'd like to echo Stefano in just thanking the audience, all the speakers, and looking at all the videos. It is absolutely amazing what this community does. It really is. It's the depth and breadth of knowledge and expertise is amazing. All formats, sciences, all disciplines. It is amazing, and I'm proud to be a part of your community because it's an amazing place. And with that, I'd like to, we're all excited about heading over to Barcelona. It's gonna be fabulous. Getting to see Marseille again. It's been a year or so since I've seen her. I'm so excited. But we want to wrap this up here. We got one more session, but I thought while we had us all together, I'd love to thank our sponsors again, because without them, it would have really been much more difficult. The Office of Vice Chancellor Research, they did a lot to help us out, as well as the School of Data Science and Society, and UNC Global, who helped us quite a bit. Top of the Hill for some great beer, and just all the other support from UNC that done a whole lot. But at the top of this list, and I know as a researcher, I guess you got to admit your implicit bias, and I have plenty of it here. And I have a lot of implicit bias here, but the teams that I've worked with and for 32 years, the Odom Institute, all the folks there at the Odom Institute, and now the folks at the Research Data Management Corps, I asked them a huge task. 2 years ago, we took a group that was doing the work for the social scientists and literally put them up, moved them over to the central office and asked them now, guess what? You got to solve Michelle's problems. You've got to solve the clinical trials problems. You got to solve the genomics problems. You got to solve the chemist problems. You got to solve the physicist problems. And it goes on and on and on. And we've added a few people and they're absolutely wonderful. I love the whole team. We have built a great team. We need to add more. They'll tell you we need to add more. We're trying. We're doing our best. But I am biased, but I believe it's the best team on the planet. And this event would not have happened if it weren't for the teamwork, all of them, led by Heath and Blair, who are fabulous. Everything went smooth. They stressed out the whole time to make it perfect. And I will tell you, I didn't have to stress out because they were, and they made it perfect. They're just such a great team. So Heath and Blair and everyone else, I echo Philippe's comments. They're just so good. And I thank all of them and thank people for showing up. We've got the folks here from Odom, Luna. It is just fabulous. We share, Luna helps us. She's helped us with all the video. It's just amazing. And Jessica and Michelle and everyone, I really appreciate all the support from the folks here at UNC that just chipped in. And it is just an amazing event. I really think it's amazing. It's going to be amazing as we move forward and head over to Barcelona. It gets better and better every year, I think. We'll copy this from IAssist. I think at the end of every IAssist, they say this is the best IAssist ever. And I do think we're going to get better and better and better as we go forward. So thank you all for attending. We still got a couple more great talks, but while everybody's here, I wanted to tell everybody thank you. One more quick announcement. John Martin's got an
This is just an extremely formal announcement. Most of that have last for so I'm inviting all of our staff over this evening for a very, very low-key pizza and beer kind of decompression evening. If anyone is in town still this evening and would like to join us, I would like to welcome you as well. So come find me after this and we'll make that happen. I can give you directions and all of that. So thank you once again.
Got about 3 minutes to the next session, bro. Yeah. Oh, we've got to clear this up, okay? We've got to clear this up. So, yeah, I didn't read this, Stephanie. This morning we had, it was early because some of the cup participants weren't here. We had an informal raise of hands this morning to figure out who won the Dataverse Cup, because we had some conflicting information, but I have the real knowledge now because the boss showed up and Stefano has absolutely guaranteed us that his team won and Gustavo lost. So there's always next year in Barcelona. So be ready. Thanks, everybody.